Hi, and welcome to this final installation of our notes for this unit, where we finish off talking about maps. If you remember, the 7 elements of maps we want to keep an eye out for are summed up by the acronym TALL dogs. So today we're going to do 5, 6, and 7, the OGs, starting with the O, orientation. Orientation shows the directions on the map, which is pretty standard. It's something you probably are familiar with. It usually uses a compass rose, which is what this thing right here is called. You'll usually have north up, south down, west to the left, east to the right, but that's not always the case. You could just as easily have an upside down world map where you had a compass rose showing south as the top of the map, north as the bottom of the map, west as the right of the map, and east as the left. So you have to pay attention to your compass rose, especially when it's a peculiar map or a large scale map, which is the name for a map that only covers, say, a small amount of territory, like, say, the middle of Mongolia. Next up is the grid, the G part of Tall Dogs. These are the imaginary lines that divide or organize space on a map. They help you find things wherever you are on a map. If you're, say, looking for a specific city, you can look in the index of your map, of your atlas, and it'll tell you what page and where on that grid you need to look. For instance, if you were going to try to describe the location of and this would be the absolute location, the absolute location of Snickers on Junk Food Island, you would tell your friend what? If you said 4D, that's correct. This is not the usual way of dividing up a map into a grid, though. It's something we're familiar with, latitude and longitude. So this, once again, something you're familiar with. It gives every area a unique spot on the grid. And the final element of maps is scale. The scale shows how the distances on the map compare to the actual distances on Earth. When you're looking at a map you're really familiar with, like, say, a map projection of the entire globe, you probably don't need to look at the map too much. You have a general idea of how big things are. But especially when you're looking at an unfamiliar map, when you're, say, driving a car, you really need to pay attention to your scale. There are 3 main types of scales that are used. You could be looking at a verbal scale, which, on a map, it would say something like 1 inch represents 2,000 feet. So if you took out a ruler and you marked off, say, 10 inches on the map, then you would know that those 10 inches corresponded to what distance in the real world? If you said 20,000 feet, then you'd be correct. And this is not as common as it used to be anymore. You won't see too many verbal scale maps on current maps, but you will on older maps, and we'll be looking at a bunch of those. There's also, we'll skip the middle one and go down to the fractional scale map, which gives you a fraction. It says 1 basically is equivalent to some larger number, 1 whatever. So if you're looking at 1 inch on your map, that would correspond to, if the scale said something like 1 is equivalent to 100, if you were looking at 1 inch on your map, then in real life, whatever was depicted on that 1 inch would be 100 inches long. If the fractional scale was 1 to 1 million, then if you were looking at, say, a foot on the map, say it was a large map, and you marked off 1 foot of that map, then in real life it would represent a distance of 1 million feet, which is covering a pretty big area. Now this middle one, this linear scale, is what you'll mostly see on maps these days. And when you're looking at a linear scale, you could, say, get out a piece of paper and measure it up against this this distance, which is written on your map. And you know that wherever there's two things are this far apart on your map, they are 2,000 feet apart in real life. And obviously you can divide this up into smaller distances using little hash marks. So if something was, say, maybe if you're trying to find out how far X is from Y in real life when they're shown as being this far apart on your map, if you took out a piece of paper and measured this example that you have against this distance, you would see that, all right, that looks like about 2,000 feet right there, and then you add on that much more, and so it's about 1,000 extra feet. So in real life, these are about 3,000 feet apart, X and Y. With this map of South Carolina, you see the scale down here. So if we were trying to find out how far Columbia was from Charleston, you could get a sheet of paper and put it up against the scale right there, and then, mark on the sheet of paper how big it was, and then lay it down right here, and it would take you about there on one repetition of that sheet of paper. So you could tell us, all right, it's about 60 miles from Charleston up to just outside of Orangeburg, and you'd look at your piece of paper from here to here, and you'd say, okay, that's not quite the whole distance, not quite 60 miles. So you make another little dash on your piece of paper. You hold it back up against the scale down here, and you see that it ends up being about 50 miles long rather than 60 miles long. So you can estimate that the distance from Columbia to Charleston is about 110 miles, give or take, more or less. So that's one good way to use this type of scale. And one thing to keep in mind, some words that we're going to be seeing quite a bit: small scale maps and large scale maps. Just remember that when you hear these terms, it's opposite day. A small scale map covers a very large area. But a large-scale map covers a small area. Kind of confusing, but just a vocabulary term you should be familiar with because you'll probably be hearing it. Whew. All right, good job. I think we're done.